The purpose of this video is to run through the use of an operational verification when confirming DeltaV IO is as it should be, and that the tags and the variables used in the DeltaV system are appropriately linked. And it's a case that the DVIO watch application can be used during the kind of the pre-FAT stage, and then also it can be used then once you're actually in the middle of your qualification. Okay, so first off, I'll set the scene just a little bit. So in terms of the verification sheet, as I said, it has the detail relevant to I/O and tags as such and variables really in DeltaV, and then you have then variables inside of an actual PLC as well. Which have this kind of link together, and you'd normally see these variables here. Say, for example, on an IO index, you might have the variables from the PLC, and then you have then variables which should really be referred to in some other form of index where you have delta V mapping across. So normally, if you're in a situation like this, say for example we have this purified water system, and we'll pretend say that this is actually a vendor package is controlled by say a non-standard PLC, maybe say a Siemens PLC, and our Delta V system has to reach out to it. And we might want to take control of some of the instruments, but certainly we want to do readings from the separate vendor package. And a typical scenario here, say I have this valve and it's going to take in actual water from our purified water system to fill a tank. So if I open up the Delta V system here, I have DVIO watch. It's just looking at one valve only at the moment. It's looking at the actual the variable that presses the actual control module as such to open, and then we also have a ZSE and a ZSO. Here I have the typical kind of Delta V faceplate that you can use to do a manual open and a close as well. And to set the scene as well, what you'd normally expect is you'd have some form of a loop drawing like this, where you basically have like a solenoid, you have a ZSE, a ZSO, you've got some kind of a standard pattern here in the background, and then as well as your marshalling and say your junction box details, if you do it right, and as I would see it anyway, you would literally link back to the PLC variables as well. So you've got this lovely match that goes back to your operational verification, and your IO index as well is in good shape. You know that there was nothing, that the boundary between the verification of the wiring in terms of that installation and then the standard check from the actual screen, that the barrier isn't too great and leaving lots of room for error. So just as an example, I have then TIA opens where I'm going to look at a live example and just basically step through the verification. So to give that kind of across. So at the very start, what you're going to see is the screen, and I have this guy running, and here I have a valve basically that's open. So if I go off, I can actually see live here that I actually have this valve and he's open because you can see right through him. And if I then just move back here just for a quick moment, what I will be able to see if I just go up just a little is I have an S750 and 100, and here's the IO right here. So I can monitor this IO, and if I come down just for a bit and I just go across, then I'll be able to see my valve. Okay. So essentially, in terms of how you actually compare the I/O itself, what you do is inside of, I'll actually just open up the control studio. So inside Delta V, what you're going to see is individual control modules. It's like instances as such of a template. And here we have like a standard valve. And if I go back, you can open up then individual control modules, and you're going to be able to basically see that there's like a ZSE, a ZSO, and then we're going to have like this valve out guy. And here using the DVIO watch application, I can see the actual current values of them, but also then on the screen itself, I can see that the valve is down as being green. So I can see the values which are there. And when if I just for the sake of this, in terms of the operational verification, I literally just go back and we'll take a look at our particular valve that we witness in the field. I'll just give him a close. So here I can see the values change, and if I open up, I can actually just zoom in here, and I'm going to see this ball valve actually go and do a close. And then in terms of the verification as well, we can take a look here, and we can see that we're on our way to having the ZSE and the ZSO for this XV01 valve actually modulate as well. So in terms of developing a document where there is areas to go wrong, ideally you will have some form of an OPC server map, such as this done in the background where you're doing the link and so on. But the operational verification is great as an absolute bottom line from a person who wants to kind of witness something in the field, see it happen, and look at the bottom line down at the PLC level, as well as the bottom line up at the actual the HMI and the kind of the tag logic level in DeltaV. Thank you very much.